So obviously I haven't given you a lot of introduction about linear equations. I've just given you some information and said off you go. It's intentional. I wanted you just to have a crack at this. So on the axis below, I asked you to draw a linear function. If you have drawn a straight line through any part of that function, you've drawn a linear function. Through any part of that axis, you've drawn a linear function. So I could draw that. I could draw that. I could draw that. I could draw that. They're all linear functions. Cool? So providing you've done something like that, your answer's correct. Which one of those should I keep? Give me one to keep.
That one.
That one?
Yeah.
Or that one? We'll go with this one. Okay, I'm just going to assume you meant that one. So I'm getting rid of all the others. Just going to leave that last one there. And I'm going to look at the other side of the board for a second. Should not have drawn through as my axes. Okay. That's not what I wanted to do. There's my gross looking linear function. Sweet. Yours is probably looking something like that. This line can be expressed with an equation. What do I know about that little plus or the big plus sign that I've drawn on the board? Is that the first time you've seen one of those big plus signs with numbers on them? What do we call that?
Cartesian plane.
Cartesian plane. What does this vertical line represent? Riley, what do you reckon?
The y-axis?
Yep, and what about the horizontal things, Lucy? X-axis, very good. So what I'm basically saying is that I have a relationship between the vertical and the horizontal. Sweet. As my horizontal increases, what happens to my vertical? As I go this way, do I go up or do I go down? Up. Sweet. We can represent that with a mathematical equation. We're going to talk about that over here. Some of you have seen this more recently than others. Others probably going, I haven't seen that ever before. You have, it's just a little while ago. So we're going to refresh it and assume you know nothing about this. I've asked you to create an equation for the line that you've drawn. I'm going to show you how I did mine and then give you a chance to do yours. Now, I haven't picked nice numbers, intentionally so, because this works for any function. I'm going to start by inspection, looking for one of these values. I've got C and M. Are they the only letters that I've got in that equation? What else have I got? X and Y. Why don't I have a special rule for those? What can X be? Anything on that line, correct? And when I have an X value, there'll be an associated Y value. So if I've got X equals 4, there'll be a Y value up here somewhere, won't there? Sweet. Providing I know my M and my C, I can find that out. But before I do that, I need to find my M and my C. So I need to look at what do I know. So I know my M is my gradient, and my Y is my C is my y-intercept. What is a y-intercept? Where does that occur, Harry?
It's when the like a line crosses the y-axis.
So when the line crosses the y-axis. Cool? I've done this very roughly and I don't want to get bogged down. Looking at that line, where do you think that crosses the y-axis?
2.2.
A little bit more than 2, maybe 2.2, 2.3. Happy with that? So straight up I know what about my function? Y-intercept, which is my C. So in this scenario, I look at my graph and I say, look, it's 2.3. If it was more high stakes, what would I be doing? Would I be approximating that? Or finding that out in a more certain manner? If your life depended on that being at 2.3, would you take the bet?
No.
Okay, not really. You wouldn't take the bet? Fair enough. So if it's a low stake environment like what we're doing now, we're just trying to get our head around functions in the activity we're going to be doing. You can do that for your y-intercept. If it's a bit more high stakes, like an exam, there are other strategies. Sweet. That's a good one for now. So we know our C value. What do we not know now?
Gradient.
Our gradient. So we find our gradient by using the equation rise over run. Sweet. So I'm going to pick 2 points. Any 2 points on my line. Tell me when I should stop moving my finger. Cool. Right, so let's take that one there. Keep going. Tell me when I should stop moving. So you picked you're very kind to me. Okay, so Keith's picked two really nice points for me. He could have picked any points, but they're really gentle ones for me. How much has this function risen?
It's risen 2.
Yeah, about 2. Where do we start at?
Oh, we started at negative
Vertically. Vertically. Where do we start?
0.
0, and we finished at?
2. Oh, 2.2.
2.2, but about 2, correct? Happy with that? So how much has the function rose? Started at 0, went to 2.2. It's gone up 2.2, hasn't it? I'm going to write that as 2.2 minus 0, or 2.3. I've got 2.3, so I'm just going to keep with 2.3. Are we happy with that? That's how much it's gone up. So I've gone 0.2 minus 0.1 divided by, how much has it gone across? It started at negative 2 and it went to?
0.
So how much has it gone across? What's the run? 2. Positive 2, correct?
Yep.
I'll just put it in as 2 for simplicity's sake. Okay. I'm just going to put it in as 2 for simplicity's sake for now. So the gradient of that, what's 2.3 minus 0? 2.3. So 2.3 divided by 2 is my gradient for that function, which is
1.115.
1.15. Very good mental math. I now know my M and my C value, correct? So Y equals 1.15. What's the operation between the M and the X? Times. So I just write that as X plus 2.3. Mate, I'm going to perform a magic trick, alright? It's pretty magical. You give me an X value and I'll tell you the Y value. 4. Alright? So you're saying let X equal 4. And I'm going to tell you what the Y value is. We'll see if it makes sense. Because that should be about here, right? So we should get a fair idea about, what do you expect that's going to be? If you followed that line through. About 5? Yeah, let's have a look. So Y equals 1.15 times 4 plus 2.3. That's 4.6 plus 2.3, which equals 6.9. Very good.